So in this video, we're going to talk about mathematical relationships and interpreting graphs. Pretty straightforward, short video here, not too much detail, but I do want to give you the basic understanding of the different types of relationships we're going to see in some of the physics equations we deal with, the problems we deal with, and some things we've actually already seen too. So to start with, we talk about relationships between the two different variables. You have your independent variable and your dependent variable. And the first relationship is what's called a direct relationship. Pretty straightforward. Means that as one variable increases, the other variable increases. So you can see on this graph, graph 1, graph 2, and graph 3, as x gets bigger, y is getting bigger. Okay. The one thing that's consistent here for all three of these graphs, no matter what, the slope is positive. So the slope on all three of those graphs is always positive. So in a direct relationship, that is going to be the case. Again, that means as one variable increases, the other variable increases. It also means that if one variable is decreasing, the other variable is decreasing as well too. Okay, but it all fits within that category. And if you plotted direct relationships, they'd always have that positive slope. The other relationship we're going to have is an inverse relationship. This is as one variable goes up, say x gets bigger, y is going to get smaller as we go along. That is an inverse relationship. Okay. In this case, you are always going to have a negative slope. Okay. You can have again, it doesn't tell you anything about the shape of the graph. It tells you the slope of the graph, something about the slope of the graph. So that 1, 2, and 3 are all inverse relationships. Even if they're linear, quadratic, whatever function they are, it doesn't really matter. We just know that as x is increasing, y is decreasing. Or as y is increasing, x is decreasing. Okay, so we have that inverse relationship between the two variables, and we end up with a negative slope in the graph. Now, some of the different types of graphs we're going to see, common physics functions. The first one we saw with our period and angle graph. Once we graphed everybody's data, we saw there's no relationship graph. Okay, this is when you change the independent variable changes, the dependent variable is going to remain constant. So we can graph that with the equation y equals k, where k is a constant. So k is constant, so it's some value. In this case, it's 2 for this graph, but that is a graph where there is no relationship between the two variables. Okay. The next graph is a linear relationship. This is where as x is changing, or the independent variable is changing, the dependent variable is going to change, but at a constant rate. So for every, in this case, for every 2 you go up, 2 you go to the right, okay, it's going to go up by 6, right? So it's going to have a slope of 3 equals the slope 6 over 2. So understanding that a linear relationship, you're going to have that constant slope the whole time is going to be the key. And again, linear function, most of you should remember this, y equals mx plus b, where m is the slope and b is the y-intercept. And again, that is just whatever the dependent variable's value is when the independent variable is 0. So another common physics function, we'll see it a lot with some of the things that we do. Okay. Third one is going to be the inverse relationship. This is like your pressure volume graph that you created using the simulator. As the independent variable increases, the dependent variable is going to decrease inversely. So this is going to be graphed by the function y equals k over x. Okay, and the key with this function is it's never going to reach 0 and it's never going to hit the y-axis. So it's never 0 on y, and it never intercepts the y-axis. So those are the two keys there with an inverse function. Okay, and again, function there is y equals k over x, where k represents some constant. Okay. Fourth function here is fourth relationship is the quadratic relationship. Okay, we'll see this a lot, where the independent variable increases, the dependent variable is going to increase by the square of x or some kind of function thereof. Where you're going to end up with the equation, the expression is y equals ax squared plus bx plus c. Okay. We'll have a couple different formulas we use where you have this squared function in it, and when we graph it out, you'll see that curve, and that exponential is what's going to fit the model there, that polynomial. And our graphing programs will tell us what the a, b, and c values are for a given function. Okay, you won't have to figure those out; they'll be given to you. The next and final one is the square root relationship. Okay, this was our period versus length graph that you saw. As the length increased, the period increased as well, but increased by the root of x. Okay, so it's going to start increasing with this deeper slope here, but then that slope is going to steadily fall off, and that's going to be given by the function y equals the square root of x, or k times the square root of x. Okay, there may be other factors in there too, but for the most part, the keys that we care about is that constant times the root of x, understanding that this is going to it's going to steadily increase, okay, but it's going to increase at a slower rate as we go along. So the slope is changing as we go. The one thing to note here is, if the graph, we're talking about this part of the graph, this is still a direct relationship. Because the slope is still always positive, even though it's decreasing. So that's important to remember, is that direct versus inverse only matters what the slope is at any point in time. Doesn't matter about that change in the slope. So those are our common physics functions and our two mathematical relationships. So hopefully that makes sense. And we'll kind of use those throughout the year to look at different relationships that we see.